Hello everyone. Today we're gonna do a demo for Lab 3 data communication. And we'll start with part 1. Part 1 is basically for configuring IPv4 static and default routes. So our first step was creating the topology. I built this small network using two Cisco routers and two switches and two PCs. For the routers, we used a DCE cable for the one link, and others straight black cable, Ethernet cables. Then we filled the addressing table with our IPs, 16, whatever. Let's begin with task one. Task one was just to cable the networks from the below. And then task two was basically configuring the IP addresses. I assigned the IP addresses based on my addressing table. R1's data interface is 192.168.0.16 and the serial interface is 10.1.1.1. R3's LAN is blah blah blah. It's all written in the addressing table. And each PC got its IP and default gateway pointing to its router. Once configured, all link lights turned green, meaning the interfaces were active. So we checked the initial connectivity using the ping, but however, we had a problem. Everything was pinging right. However, when I tried to ping PCA to PCC, it wasn't working, or to the loopback. PCA wasn't able to connect even to the loopbacks. So this caused a problem. Why? Because the routers couldn't connect between each other. The PC was only able to connect to its router as the end, and it couldn't go to the next router. So here we need to create static routes. So for static routes, we create a recursive static routes for our R1. Why is it called recursive? Because it basically recurves. It basically recursive because the router must look up where the next help is located before it sends the packets. And for the R2, we created a direct route. Why is it direct? Because it sends the packets straight away, not direct away, proving that meaning only one lookup is needed, so it's slightly faster. This is for the directly connected, and then we configured the static route as we said. So now basically we try to verify it, and we can see that PCA is now able to ping. It was able to ping PCC. And then for the next step, we just remove the static route so we can start the next step, which is the loopback, which is the default routes, routes, I mean. So here we configured on routes on R1 to reach R3's loopback network. What's a loopback, by the way? A loopback is like a virtual interface inside the router. It doesn't use the cable. In real networks, it's used for testing, but here it simulates extra remote networks behind R3. After adding the loopback R1, R1 could like ping those loopback IPs, meaning it could outreach to all R3 simulated networks. And then I removed that. Default route, loopback route, and I added a default route. So it's called a quad zero route, and here's the command. It's IP route 00000, and then I removed them with the. So basically, when I check the verify, I can see here it's written here, verified here, and the gateway, of course, is the serial 0001, of course. And I checked the possibility to ping, and yes, it was able to ping. Means everything was connected. And here are some reflection questions I answered. They're basically just theory. They aren't related to. They are related, I mean, but they are not related to packet tracer itself. They're just theoretical. Now for part two. Hello everyone. Now we're gonna do part two. In lab 3, part 2 is about configuring basic RIP2. I want to explain first what's RIP. RIP is in routing information protocol. It basically makes routers self-update. If you add a new network, the RIP will automatically spread the information without needing the manual static routes everywhere we need to add. First, here you can see our first topology. We added it here. You can see it here. We implemented the topology and we implemented the IP addresses and the routes and everything based on the addressing table right here. You can see here we changed the addressing table. And then we started with the tasks. Of course, we've done all of these and we tested connectivity. We've tested the routers to check everything is going right. And then we verified the RIPv2. How do we run RIPv2? We run it using, after going to config, you go to the router and then version 2, and then you choose the network and everything. Of course, I forgot to mention this, but here I choose R1 as the DCE and R2 as the DCE, just like the dressing table. And after configuring this on R1 and R3, I used passive interface G01 to prevent the RIP updates from being sent out into the LAN, and then examining the current state of the network. So we want to check if the PCs are actually sending. Is it, can you ping from PC A to PCB? And we figured out that no, we can't, because there are different sub-routers and the routers don't have routes yet. And PCA to PCC as well, we couldn't ping, no. PCC to PCB, no, we couldn't. There's no route. And PC to C also we couldn't, because there is no PC route. Then we verified that RIPv2 is running. When we started, we can see here debug IPRIP. It showed us that RIP protocol debugging is on. I can show in the packet trace, but it will take so much time. And you can see also using this what version is running as well. Our router RIP version 2. Going down in the report. Also here, when you show the show IP route, it will give you the whole information. The update coming from R3 was source 10.2.1 on serial 0/0/1. Then the next step, we turned off the auto summary, and we cleared the IP routes, and then we can see that here. You can see here that there is RIP updates being sent from R3. We can see received RIPv2 updates, blah blah blah. And we can see as well that the subnet mask was included in the routing updates. Next step, we verified everything and we checked that it actually worked. And of course, here we wanted to configure a default route for internet access. We simulated R2 to be the internet. So basically, if the destination is not in the routing table, just send it here to R2 to the PC to PCB. I mean, PCB will be simulated as the internet. If anything is not available, just send it to PCB, and verify the routing configuration. And then we check the connectivity here. For example, you can see PCA. If we can ping this one, it worked. We can see that the ping worked very well. Also, PCB, we can see the ping. The ping works well. And here are some reflection questions we answered. Why do we turn off automatic summarization? Because it advertises the exact subnets instead of summarizing to classified. Why is that? Because turning off auto summary will allow us to prevent incorrect routing and routing black holes by ensuring all routers know the specific subnets. And that's the end of our demo today. Hope you enjoyed and learned new things. Thank you.